Good evening, students. Am I audible? Is the board clear? Students, am I audible? Is the board clear? Please reply in the chat box. Board is give me a minute then. Just give me a minute. Now is the board clear or is it still blur? Now is the board clear or is it still blur? आता त्यांना ब्लर दिसतोय आता हा आता क्लिअर आहे. माझा मोबाईलचा डेटा यूज करतो. त्यामुळे ब्लर होता. मी डायरेक्ट माझ्या मोबाईलला कनेक्ट केलं राहू द्या. चालेल. Okay, so we are going to start with the problems previous years. So for x belongs to 0 to 1 by 4, if if derivative of tan inverse of 6x into root x upon 1 minus 9x cube is root x into g of x, then the value of g of x is, the options are a 9 upon 1 plus 9x cube, option b 3x root x upon 1 minus 9x cube, option c 3x upon 1 minus 9x cube, and option d 3 upon 1 plus 9x cube. Okay, this has come in the year 2017. Means it has come in GWE means in 2017. So he is saying us that the derivative of tan inverse of 6x root x, 6x, let me see, yes, 6x into root x upon 1 minus 9x cube is root x into g of x, then we will have to find out the value of g of x. Okay, let us try it. So y is equals to tan inverse of 6x into root x upon 1 minus 9x cube. now we directly don't take the derivative. We have done a lot of numericals, and I've said that we'll directly will not go for solving this. And here substitution is also a little bit difficult because the substitution basically is when you take sine inverse, you get 1 upon under root of 1 minus x square. When you take tan inverse, you get 1 upon 1 plus x square. And the derivative of, okay, sec inverse is 1 upon x into under root of x square minus 1. So if this kind of terms are there, then we take x is equal to tan x, tan of theta or sine of theta or sec theta. Okay, but we don't have any kind of the term. See here now, I guess. Just wait a minute, then I'll just. Now is the both clear? Or still it's the same? Is the both clear now? Okay. Okay. So here if you see the terms, we have 6x root x upon 1 minus 9x cubed. Okay, we don't have any kind of substitution over here to make the things easy. Then we will have to think of something else because we directly will not be able to do it. Because if I directly apply the chain rule, I will be in trouble. So then, when it is tan inverse, then I should think about tan. So if I remember correctly, then we have a formula. 2 tan inverse of x is nothing but 2x upon 1 minus x square. We have a formula. 2 tan inverse of x, and inverse trigonometry, we had this formula. 2 tan inverse of x is equals to 2x upon 1 minus x square. So if I'm able to convert this, okay, in this terms, then I'll be able to write it. Okay, then I'll be able to solve it. So that is what I am going to do. So that is what I'm going to do, which can also be written as tan inverse of 2x. So y is equals to tan inverse of 2 into 3 into x. Root x can be written as x raised to 1 by 2 minus 1. 9 can be written as 3 square into this x cube. Therefore, I'll get y is equals to, I've made a mistake, I guess. Yes, it is tan inverse of 2x upon 1 minus x square. Okay. So that can be written as 2 into 3x raised to 3 by 2. So here also I can write 1 minus 3x, okay, the whole square. Okay, so now this, when I remove the square, I'll get 3 square, and here 2 upon 2 will get cancelled and I'll get x cube. So now if you see, it is exactly this 2x upon 1 minus x square. So if I consider this entire term as x, okay, 3 into x raised to 3 by 2. So the same term I have here also. Okay, 3 into x raised to 3 by 2. So that can be written as 2 tan inverse of x. Therefore, I can write this as y is equals to tan inverse of x. Now, what is x? X is nothing but 3x raised to 3 by 2. Now it's become easy. Now I will take the derivative. So I will get dy by dx is equals to 2 into derivative of tan inverse of x is 1 upon 1 plus x square. So that will be 3x raised to 3 by 2 the whole square into d dx of 3x raised to 3 by 2 by chain rule. So I will get dy by dx is equals to 2 upon 1 plus, okay, 3 square into x cube raised to 3 by 2 into 2. So 1 by 2, 1 by 2 get cancelled. And 3 is constant derivative of x raised to. That will be 3 by 2 into x raised to 3 by 2 minus 1. So this 2 and this 2 will get cancelled. So I will get dy by dx is equal to 3 into 3, that is 9 upon 1 plus 9x cube into this x raised to 3 by 2 minus 1, that will be 1 by 2, which can be further written as 9 upon 1 plus 9x cube into root x. And here also he has given the derivative of this is root x into g of x. In the question what he has given, in the question he has given dy by dx is equals to root x into g of x. So if I compare both of this, so on comparing I can say that my g of x is nothing but equals to 9 upon 1 plus 9x cube. So our answer is option number A. Okay, so option number A is my answer. Okay, 9 upon 1 plus 9x cube. I hope everyone has understood. Take the screenshot. Take the screenshot. Everyone has taken the screenshot. Let's go to next numerical. Okay, I hope everyone has taken the screenshot. Okay. Let's go for next numerical. Okay. Next numerical, if g is inverse of function f, then the question is given if g is inverse of f and if my f dash of x is equals to 1 upon 1 plus x raised to 5, then my g dash of x is equal to option number A, 1 plus x raised to 5, option number B, 5x raised to 4, option number C, 1 upon 1 plus g of x, the whole raised to 5, option number D, 1 plus g of x, the whole raised to 5. This has come in the year 2016. 1 6. This has come in the year 2016, again in names. Okay, I have many times said, okay, the numericals will always be connected. Okay, it will not be dependent only on one chapter. To solve the numericals, you will always require concepts of two or more chapters or two or more topics, always. So here is saying that G is inverse of F, and he has given us the value of derivative of F, and he wants us to find out the value of derivative of G. So if you remember the property, if G is inverse of F, then F for G is equals to G over F is equals to X. This is the property which we had written for the inverse of a function. Okay, in relations and functions chapter, we have written a property. Okay, for inverse, if G is inverse of F, then F of G is equals to G of F is equals to X. So, I can write F of G of X is equals to X. Okay. Why am I writing F of G? Because he has given us the value of F dash of X. So now if I take the derivative of this, so d dx of F of G of X will be equal to d dx of X. Therefore, I get F into by chain rule d dx of G of X is equal to derivative of X is 1. Therefore, I get F dash of G of X into derivative of G of X will be nothing but G dash of X is equal to 1. See here now, if the board is blurred, there are two reasons again. Either the internet speed is becoming low on my side, or either the internet speed is low on your side. Okay, I cannot help in that. I have changed the connections 3 times. Okay, we have different internet connections in our office, and I have my own mobile also. So once I connected that, you said it's blurred. So then I connected with my mobile. Again, it showed you said that it is blurred. Then I connected with one more office internet where the speed is 20 Mbps. Okay, now I don't think so. Here it should be blurred. Okay, even if the internet speed is not good on your side or my side, it will be blurred. You just see if in the recorded video it won't be blurred. And still, if you have an issue, okay, I'm there in the group also in your Excel's perfect group. There you can ask me any questions if you have any queries. Okay. As of now, please pay attention on this. When I take derivative, I will get f dash of g of x into g dash of x is equals to 1. It's telling us to find out the value of g dash of x. So from here I will get my g dash of x is equals to 1 upon f dash of g of x. Okay. Therefore, I will get g dash of x is equals to 1 upon f dash of g of x. So what is f dash of x is this? So I will substitute the value of f dash of x, which is 1 upon 1 plus x raised to 5. But here I have g of x, so wherever there is x, I will substitute g of x the whole raised to 5. So it is 1 upon 1, so this will go up. Therefore, I will get g dash of x is equals to 1 plus g of x the whole raised to 5. This is my answer. Okay, so which is option number D. So option number D is my answer. 1 plus g of x the whole raised to 5 is my answer. Okay, everyone take the screenshot. Everyone take the screenshot of the solution. Okay, I hope everyone has taken the screenshot of the solution. Let's move to the next question. I hope everyone has taken the screenshot. So I'm moving to the next question. Okay. Next question is if y is equals to if y is equals to sec of tan inverse of x, then dy by dx at x is equals to 1 is the value of y is given as y is sec of tan inverse of x, and we need to find out the derivative at x is equal to 1, and the options are 1 by root 2, option B is 1 by 2, option C is 1, and option D is root 2. This is a simple one. As compared to the others, this is a very simple one. This was asked in 2012. It's simple. We can directly apply the chain rule over here. No problems with that. So y is equals to sec of tan inverse of x. So dy by dx will be equals to derivative of sec is sec into tan. So this will be sec of tan inverse of x into tan inverse of x into by chain rule d dx of tan inverse of x. Therefore, I will get dy by dx is equals to sec of tan inverse of x. Tan and tan inverse will get cancelled, so that will be x into derivative of tan inverse of x will be 1 upon 1 plus x square. So this is the value of dy by dx, but it is asking us at x is equals to 1. So we'll put x is equals to 1. So at x is equals to 1, I will get dy by dx is equals to sec of tan inverse of 1 into 1 into 1 upon 1 plus 1 square. So I will get dy by dx is equals to sec of tan inverse of 1 is pi by 4. So that will become sec of pi by 4 into 1 upon 1 plus 1 square. So that is 1 by 2. So I get dy by dx is equal to sec of pi by 4 is root 2. So root 2 upon 2. So It will be root 2 upon 2 can be written as root 2 into root 2. So 1 root 2, 1 root 2 gets cancelled. So I'll get dy by dx is equals to 1 by root 2. This was a simple one. So yes, our answer is option number A. The value of dy by dx will be 1 by root 2. This was a simpler one. Take the screenshot of this. Take the screenshot. Okay, I hope everyone is taking the screenshot. Let's move to the next question. Let's move to the next question. This is a little bit tricky one. d2x by dy square is equal to option A d2y by dx square raised to minus 1. Option B minus of d2y by dx square whole raised to minus 1 into dy by dx the whole raised to minus 3. Option C d2y by dx square into dy by dx raised to minus 2 and option number D minus of d2y by dx square into dy by dx the whole raised to minus 3. This is a good one and a tricky one also. This has come in the year 2007. See, here the question is giving d2x by dy square means derivative of x with respect to y, and that also it is written d2x by dy square. It means, okay, two times we have to take derivative of x with respect to y. But in the options, if you see, all the options are dy by dx, dy by dx. He wants derivative with respect to y over here, but all the options are given as derivative with respect to x. So it's a bit of tricky one. So let's try. So dx by dy can be written as 1 upon dy by dx. Right? So this dx goes up. So I can write dx by dy is nothing but equals to 1 upon dy by dx, which can further be written as dy by dx raised to minus 1. Okay, 1 upon x can be written as x raised to minus 1. So similarly, 1 upon dy by dx can be written as dy by dx raised to minus 1. Now here it is second order derivative, means here I will take the derivative with respect to y. So dy of dx by dy will be equal to dy of dy by dx the whole raised to minus 1. So this will become d2x by dy square is equal to. Now you directly cannot do derivative because here you have derivative with respect to x, whereas here I am doing derivative with respect to y. Therefore, I will have to think of something else. I will be able to take derivative only if here it is with respect to x. Therefore, what I am going to do is, okay, so this dy I just shifted over here, and here what I did is I multiplied and divided with dx. Okay, what I've basically have done is I've multiplied and divided by dx. Why? Because we don't know, we have not, we are, what we are doing is the direct derivative which is there in a syllabus and not partial derivative. Therefore, you can do derivative only with respect to one variable. Now I have two variables over here, hence I have to do this. Okay, so what I did is I just adjusted, I have multiplied with dx and dx. So now I can take the derivative over here. So I will get d2x by dy square is equals to x raised to minus 1 is minus 1 into x raised to m minus 1 into, by chain rule again it is not x, therefore I will have to take derivative of this term, that is d dx of dy by dx into this term is already there, which is dx upon dy. So I will get d2y, sorry, d2x by dy square is equals to minus 1 into dy by dx, the whole raised to minus 2, into this will become d2y by dx into dx by dy. Okay, which can further be written as d2x by dy square is equals to, this minus sign I am writing with this, minus of d2y by dx square into this dy by dx, the whole raised to minus 2, and here dx by dy I can write it as 1 upon dy by dx. Okay, so dx by dy can again be written as 1 upon dy by dx. Therefore, I will get d2x by dy square is equals to minus of d2y by dx square into dy by dx, the whole raised to minus 2 into 1 upon dy by dx can again further be written as dy by dx raised to minus 1. Okay, the way we can write 1 by x is equals to x raised to minus 1. So now the bases are same, so the powers will get added up, and therefore I will get d2x by dy square is equals to minus of d2y by dx square into dy by dx raised to minus 3. So which is the option? Let us see. Option number D. Okay, so option D is our answer. Option D is our answer. So it was a tricky one. Everyone take the screenshot of this. Everyone take the screenshot of this. I hope everyone has taken the screenshot. I hope everyone is taking the screenshot. Let's go for next numerical. Okay. Let's see next numerical. If f double dash of x, if f double dash of x is equals to minus f of x, where f of x is continuous and double differentiable, where f of x is continuous also and is double differentiable, which means I can take its derivative two times. Is double differentiable and g of x is equals to f dash of x, and if capital F of x is equal to f of x by 2 the whole square plus g of x by 2 the whole square, and f of 5 is equal to 5, then f of 10 is how much? Option number A 0, option number B 5, option number C 25, and option number D 10. This has come in the year 2006. This has come in the year 2006 in IIT exams. Okay, read very carefully. So he has given a function f of x. It is continuous and double differentiable. This, anyways, this condition is necessary. Continuous, then only the derivative exists first. Second, if and only if it is double differentiable, the second derivative will exist. Otherwise, it is not going to exist. Okay. Two things. Third he has given us something g of x also, and the capital F of x is something like this, and the value of f of 5 we have given us 5. Then what should be the value of f of 10? F of capital 10. Now till we don't know the value of f of x in g of x, it's not possible to find out the value of f of 10. Okay. Or suppose if I find out the value of derivative and suppose it comes out to be constant, then also we can find out the value. So let's do that. So I'm taking this f of x is equal to f of x by 2 the whole square plus g of x by 2 the whole square. Now let me take the derivative. So f dash of x is equal to, derivative of this will be 2 into f of x by 2 into derivative of f of x by 2 plus similarly derivative of this will be 2 into g of x by 2 into derivative of g of x by 2. Therefore, I will get f dash of x is equals to 2 into f of x by 2 into derivative of f of x by 2 will be f dash of x by 2 into derivative of x by 2 will be 1 by 2 as per the chain rule, plus 2 into g of x by 2. The derivative of g of x by 2 will be g dash of x by 2 into derivative of x by 2 will be 1 by 2. So this 1 by 2 and this 2 will get cancelled, this 2 and this 2 will get cancelled. Therefore, I will get my f dash of x is equals to f of x by 2 into f dash of x by 2 plus g of x by 2 into g dash of x by 2. Let me do this as equation 1. Now, in the data he has given us g of x is equals to f dash of x. At the same time, he has also given us f double dash of x is equals to f dash of x. Now, if we see f dash of x, so I can replace this by g of x, or I can replace g of x as f dash of x. Either of the thing is possible. What remains here is this. Either everything should be in terms of g or in terms of f or in whatever. So I will have to find out the value of g dash of x. So let's go with this condition. F double dash of x means, it simply means d dx of f of x. The meaning of f double dash of x is nothing but d dx of f dash of x, which he has given as, minus f of x. Sorry, I made a mistake. Now, as per this data, f dash of x is nothing but equal to g of x. So instead of f dash of x, I'll put d dx of g of x is equals to minus f of x as per the given data. So this d dx of g of x is nothing but g dash of x, which will be nothing but equals to minus f of x. Then substitute this value. This is my equation number 2 and this is my 3. So now I have the value of g of x also. I have the value of g dash of x also. So I'll substitute this value in equation 1. So put 2 and 3 into 1. Therefore I will get f dash of x is equals to f of x by 2 into f dash of x by 2 plus g of x. So instead of g of x, I can write f dash of x. Hence, g of x by 2 will be equals to f dash of x by 2 into g dash of x by 2. G dash of x is nothing but equals to minus f of x. Therefore, g dash of x by 2 can be written as minus f of x by 2. Therefore, I get my f dash of x is equals to f of x by 2 into f dash of x by 2. This minus plus will become minus. F of x by 2 into f dash of x by 2. So the terms get cancelled out and I will get, therefore, my f dash of x is equal to 0. Now what I get is derivative of capital F of x is 0. What does it imply? It implies that my f of x should be a constant. Then only the derivative will be 0, right? We know that derivative of a constant is 0. So if I'm getting, the derivative is 0, which means my f of x should have been constant. Then only my f dash of x will be 0. So if it is a constant function, which means my f of x is a constant function, it means that my f of 5 will be nothing but equal to my f of 10 will be equal to f of any value, and f of 5 is 5, therefore my f of 10 or f of 100 or f of 1000, whatever it is, will remain the same. Why? Because it is a constant function. Therefore my f of 10 will be 5. Therefore what is my answer? Option number B. So option number B is my answer. Hope everyone has understood. Okay, please take the screenshot of this. If you have not understood, then unmute and ask me what you have not understood. Everyone, please take the screenshot. Everyone has taken the screenshot. Okay, I hope everyone has taken the screenshot. Let's go for the next numerical. So the next question is if log of x plus y is equals to 2xy, then value of y dash of 0 is option number A 1, option number B -1, option number C 0, and option number D 2. This is come in the year 2004. Till I rub the board, you guys try this numerical. Try this numerical till I rub the board. Again, this is also a little bit tricky. Why it is little bit tricky? Because it's telling you to find out the value of y of 0. Which means if y is a function of x, you put x is equal to 0. But if you see the given question, it is an implicit function. You cannot write y in terms of x, or you cannot write x in terms of y. You will get a mixed answer. So now the problem is, when you find out the value of dy by dx, which is nothing but y dash, you will get the y term also, you will get the x term also. So if you substitute x is equals to 0, that's fine because he has given y of 0. But what value will substitute of y? That is where it is little bit tricky. Let's solve this. So log of x plus y is equal to 2xy. Let us take the derivative. So derivative of log is 1 by x. So this will be 1 by x into derivative of x plus y. Derivative of 2x by chain rule x into derivative of y plus y into derivative of x. So this will give me 1 upon x plus y into d dx of x, that will be 1 plus dy by dx is equals to 2x dy by dx plus 2y. Therefore, I will get 1 upon x plus y plus 1 upon x plus y into dy by dx is equals to 2x dy by dx plus 2y. So dy by dx terms on each side, on one side, and the other terms on the other side. So I'll get 1 upon x plus y dy by dx minus 2x dy by dx is equals to 2y minus 1 upon x plus y. So I'll take dy by dx as common. So when I take dy by dx as common, I'll get 1 upon x plus y minus 2x is equals to 2y minus 1 upon x plus y. Now this is what I was saying. When you take the derivative, the y term will appear over there. When I write y dash of 0, it means x I have to put 0. But what value I should put of y? So therefore what we'll do is we'll take this one. Log of x plus y is equals to 2xy. Now y of 0 implies that x is equals to 0. So at x is equals to 0. So if I put x is equals to 0 over here, so I get log of 0 plus y is equals to 2 into 0 into y. Therefore, I will get 0 plus y as y. So this is log of y is equals to 0. 2 into 0 is 0. Okay, I want the value of y. So I will take anti-log on both sides. Therefore, I'll get y is equal to e raised to 0. And we know e raised to 0 is 1. Therefore, I'll get y is equal to 1 when x is equal to 0. So I've got the point. X comma y is equal to 0 comma 1. So therefore, when my x will be 0, my y will be 1. So I'll substitute over here. So therefore, my dy by dx into 1 upon 0 plus 1 minus 2 into 0 is equal to 2 into 1 minus 1 upon 0 plus 1. Therefore, I will get dy by dx is equal to 1 upon 1, that is 1, 2 into 0, that is 0. So dy by dx is equal to 2 minus, okay, 1 upon 1, that is 1, so that is 2 minus 1 is 1. So dy by dx, that is nothing but my y dash of 0. Okay, so when my x is 0, my y is 1. So I get the value as option A. Okay, little bit tricky. Okay, so I hope everyone has understood the numerical. Please take the screenshot. Please take the screenshot of it. I'll rub the question and I'll write next question. Okay, so you guys try to solve that question by the time I rub the board. Okay, take the screenshot fast if you have not taken. Okay. Let's move to the next question. Oh, that is if x square plus y square is equals to 1, then option A, y double dash minus 2 y dash the whole square plus 1 is equal to 0. Option B, y double dash plus y dash the whole square plus 1 equals to 0. Option number C, y double dash plus y dash the whole square minus 1 equals to 0. Option number D, y double dash plus 2y dash the whole square plus 1 equals to 0. So which of these options are right? So the value is, the question is given as x square plus y square is equals to 1. So y dash is first order derivative and y double dash is the second order derivative. It means for the given question x square plus y square is equals to 1, you have to take derivative, okay, 2 times. Okay, you have to take the derivative 2 times. And then you have to see which of the options you are going to get. Okay, so everyone try. By the time I rub the board, give it a try. Okay, so let's solve it. So we have been given as x square plus y square is equals to 1. When I take derivative of x square, so that will be 2x. Derivative of y square, that will be 2y. dy by dx equals to derivative of 1 will be 0. Okay, so I take this term over there, therefore I get 2y dy by dx is equal to minus 2x. this 2 and this 2 gets cancelled, therefore y into dy by dx is equal to minus x. Okay, dy by dx means nothing but y dash. So y double dash is there in all the terms, which means I will have to take one more derivative. So let's take derivative once more. So when I take derivative, I will have to apply chain rule over here. So y into derivative, so that will be d2y by dx square plus dy by dx constant, and this derivative of y will be again dy by dx is equal to derivative of x will be 1. So this will be minus 1. So using the notation, I'll get y double dash plus this is y dash, and this is also again y dash is equal to minus 1. Therefore, I get y double dash plus y dash the whole square minus 1 will come over here. So plus 1 equals to 0. So let's see which option is there for the simple numerical. So y dash plus y dash square plus 1. So option B is our answer. Okay. So option B is our answer. Everyone taking screenshot of this. I hope everyone is taking the screenshot. I hope everyone is taking the screenshot. Okay. I guess everyone is taking the screenshot. Was a simple one. Let's go for the next numerical. If you remember, I said during the matrix and determinants in the derivative, again I'll take some numerical with determinants. So this is one of them. So let f of x is equals to x cube sin x cos x 6 minus 1 0 p p square p cube, where p is constant, where p is constant. Then by dx cube just give me a minute. Okay. Is the screen visible and clear? Okay, so see the question and you guys can try. Let f of x is equals to determinant of given where p is constant, then d cube by dx cube means third derivative of f of x at x is equals to 0 is option number 1. Option number A is p. Option number B is p plus p square. Option number C is p plus p cube. And option number D is independent of p. So he has given us a determinant. We have to find out from the determinant, solving the determinant will get the value of f of x. Then he is saying d cube by dx cube, which means whatever f of x we get after solving determinant, we have to take derivative 3 times. Okay, because he has given d cube by dx cube. And then whatever value we'll get, that will give us either option A, B, C or D. Any of the option we are going to get. So let's start solving. So here p is already a constant. We have a 0 over there, and we have sine, cos, and x cube will not go for reducing because it will become difficult. We already have 1 0 over there, so we can directly take the determinant without going for properties. We'll directly go for determinants. That will be x cube into minus p cube and p square into 0. That will be 0. Minus sine of x into p cube into 6, so that will be 6p cube minus p into 0, that will be 0, plus cos of x into 6 into p, so that will be square minus p into minus to minus minus, that will be plus. So this is the value of the determinant. So we'll further simplify. So f of x is equals to minus p cube into x cube, 6p cube minus 0, so that will be minus sine of x into 6p cube plus cos of x into 6p square plus p. So this is the value of f of x. Now he is telling us to take derivatives 3 times. So let us take the derivative 3 times. So first derivative, that will give me f dash of x. So p cube is constant. Derivative of x cube will be 3x square. So that will be minus 3x square into p cube. Minus 6p cube is constant. Derivative of sine x will be cos x plus this 6p square plus p is constant, which will come outside of derivative, and derivative of cos x is minus sine x. Okay. Then f double dash of x, taking the derivative second time. The derivative of x square will be 2x, so 3 into 2, so that will give me minus 6x, p cube is constant, minus 6p cube, derivative of cos x is minus sin x plus 6p square plus p into minus derivative of sin x is cos x. So this will be cos x. Now let us take third time derivative because he has asked us the third order derivative. So f triple dash, derivative of x will be 1, so this will be minus 6p cube. Okay, this minus minus becomes plus 6p cube. Derivative of sin x is cos x, that will be cos x plus 6p square plus p into minus derivative of cos x is minus sin x, so this minus minus will become plus. That will give me sin x. So I've got the third derivative. Now he wants us to find out the value at x is equal to 0. So I'll put x is equal to 0. So f triple dash of 0 will be minus 6p cube plus 6p cube into cos of 0 plus 6p square plus p into sine of 0. Now sine of 0 is 0, so this term will become 0. Cos of 0 is 1, so this will be 6p cube minus 6p cube will get cancelled. Hence I'll get f triple dash of 0 is nothing but 0. So there is no p term over here, so answer is independent of p. He told us to find out the value of d cube by dx cube of f of x, which means f triple dash of x. So we are getting f triple dash of x is 0, so there is no p term over there. So the answer is going to be, it is independent of p. Okay, it is nothing but independent of p. Hope everyone has understood. Take the screenshot. Everyone, please take the screenshot of this. I hope everyone has taken the screenshot. Okay. Hope everyone has taken the screenshot. Let's do next. Yes. X into e raised to xy is equals to y plus sine square x. Then dy by dx at x is equals to 0 is. So we need to find out the value of dy by dx at x is equals to 0. If my x into e raised to xy is equals to y plus n squared. If you see, it is an implicit function, so we directly we are not going to get dy by dx. Okay, we'll have to solve and then we'll have to separate dy by dx. Then we'll have to put x is equals to 0. So again, we are going to come up with a similar problem over here. Okay, at x is equal to 0 and it is an implicit function. So we'll have to find out the value of y also over here like the last time. Let's see and solve, then we'll okay, we'll see if we need to solve it. If we need to find out the value of y also. Let's solve this. So here I will have to apply u into v. So keeping x raised to y as constant, derivative of x will be 1. Then x derivative of e raised to xy will be e raised to xy into d dx of e raised to xy. Is equal to derivative of y will be dy by dx plus derivative of sine square x will be 2 sine of x into derivative of sine x will be cos x. So here I get e raised to xy plus x into e raised to xy into derivative of xy will be x into derivative of y plus y into derivative of x is equals to dy by dx plus 2 times sin x into cos x will be sin 2x. So I'll get e raised to xy plus x square a into e raised to xy dy by dx plus xy into e raised to xy is equals to dy by dx plus sin 2x. So dy by dx terms on one side and all the other terms on other side. Therefore, I'll get x square into e raised to xy dy by dx minus dy by dx is equals to sine 2x minus e raised to xy minus xy into e raised to xy. So from here I'll take dy by dx as common. So I'll get dy by dx into x square into e raised to xy minus 1 is equals to sine 2x minus e raised to xy is common. So 1 minus x into y. So one thing is good over here is x is always in multiplication with y. So even if we don't know the value of y, we can find out this. So I'll put at x is equals to 0. So let's put at x is equals to 0. Therefore I'll get dy by dx into 0 into anything is 0. So 0 minus 1 is equals to sine of 2 into 0 minus e raised to 0 into 1 minus 0 into anything is again 0. So 0 minus 1 is minus 1. So I'll get minus dy by dx is equals to sine of 0 is 0. This is 0 minus e raised to 0 is 1 and 1 minus 0 that will be. So I'll get minus dy by dx is equal to minus 1. That is dy by dx is equal to 1. So it told us to find out the value of dy by dx at x is equal to 0. So we have got the value of dy by dx at x is equal to 0 is nothing but dy by dx is equal to 1. So I hope everyone has understood. Okay, take the screenshot of this. Everyone take the screenshot of this. Okay, I hope everyone has taken the screenshot of this. I will write the next question. So the next question is derivative of sec inverse of minus 1 upon 2x square minus 1 with respect to under root of 1 minus x square at x is equal to 1 by 2 is. Try this everyone till I rub the board. Try this numerical. We have seen this kind of numericals also. Okay, derivative of one function with respect to another function. This is what has been asked over here. Derivative of sec inverse of minus 1 upon 2x square minus 1. So if you remember, derivative of one function with respect to another, I taught you something like this. U is equals to, let U is equals to sec inverse of minus 1 upon 2x square minus 1 and let V is equals to under root of 1 minus x square. Then derivative of this with respect to this means you will have to find out derivative of u with respect to v. This is what you have to find out. So if you remember, I have taught you already. So this du by dv can be written as du by dx into dx by dv. So I can find out derivative of u with respect to x. Similarly, I can find out derivative of v with respect to x, and I can substitute over here, and hence I can get the value of du by dv. Okay. So let's find out the value of du by dx. So u is equals to sec inverse of -1 upon 2x square minus 1. Directly we can't go for derivative over here because the derivative of sec inverse of x is 1 upon x into under root of x square minus 1. And we have this term. So by chain rule it will become very difficult for us. So we'll go for some substitution. Okay. And here you don't have x square minus 1. Here you have 2x square minus 1. So if we go, we have this formula. Cos 2x is equals to 2 cos square x minus 1. Okay. Hence, here I get a similar term. Therefore, I will put x is equals to cos theta. Therefore, I get u is equals to sec inverse of -1 upon 2 cos square theta minus 1. So we have this formula cos to theta is nothing but 2. Okay, cos square theta minus 1. Therefore, I'll get u is equals to sec inverse of -1 upon cos to theta. This can be written as cos to theta. We have this expansion. So I'll get u is equals to sec inverse of 1 upon cos is sec. So minus sec of 2 theta. Now I can't directly cancel sec inverse and sec because I have minus thing. So first I will have to solve this. So if you remember, we have this formula. Sec of minus x is equals to pi minus sec inverse of minus is equals to pi minus sec inverse of x. We had written this in inverse trigonometry. We cannot forget. We had written this formula. Okay, it is neither odd, neither even. Therefore, sec inverse of minus x can be written as pi minus sec inverse of x. So similarly here, sec inverse of minus sec to theta. On this same lines, I can write u is equal to pi minus sec inverse of x. Instead of x, we have sec to theta. So now I'll have u is equal to pi minus. Now the sec and sec inverse will get cancelled. So I'll get, okay, pi minus 2 theta. So from here I'll get the value of theta as, if this goes over here, cos inverse of x. So that I'll substitute over here. So I'll get u is equal to pi minus 2 into cos inverse of x. Now I can take derivative with respect to x. Therefore I'll get du by dx is equal to derivative of pi will be 0 minus 2 into derivative of cos inverse of x is minus 1 upon under root of 1 minus x square. So minus gets cancelled. So I'll get du by dx is equals to 2 upon under root of 1 minus x square. This is the value of du by dx. Similarly, I have v over here. So v is under root of 1 minus x square. Therefore, my dv by dx will be 1 upon 2 into under root of 1 minus x square into derivative of 1 minus x square. Derivative of 1 will be 0 and derivative of x square will be 2x. Okay, derivative of 1 square root of x is 1 upon 2 root x. Therefore, by chain rule I get this. Hence, I will get dv by dx is equal to minus 2x upon 2 into under root of 1 minus x square. So 2 gets cancelled. So I'll get minus x upon under root of 1 minus x square. So I've got the value of dv by dx also. So I'll substitute over here. So put values in equation number 1. Therefore I'll get du by dv is equals to du by dx. Du by dx is this 2 upon under root of 1 minus x square and 2. Okay, dx by dv. I have dv by dx, so I will have to write reciprocal of this. So that will become 1 minus x square upon minus x. So under root of 1 minus x square will get cancelled. So I'll get 2 upon minus x. So I got the value of du by dv. But he wants to find out derivative of sec inverse of x with respect to 1 minus x square as x is equals to 1 by 2. So I'll substitute the value over here. So at x is equals to 1 by 2, I will get du by dv is equal to 2 upon minus 1 by 2. So this 2 will go up. Therefore, I will get du by dv is equal to minus 4. So the derivative of sec inverse of minus 1 upon 2x square minus 1 with respect to under root of 1 minus x square at x is equal to 1 by 2 is nothing but minus 4. So this is our final answer. So in the advanced, GEE advanced, okay, either you have multiple choice, that is multiple options can be right, or many times you directly don't get the option, you directly have to write the answer. So everyone has understood, I guess. Please take the screenshot of this. I hope everyone has understood. Let me write the next question. Let me write the next question. So this is also a good one. Yes. F of x is equal to log of x to the base x, then f dash of x at x is equals to e is. So like I said, in many advanced questions, they don't give options, or if the options are there, then multiple options are there. So you guys can try this. Will I rub the board? Will I rub the board? You can try this. So this f of x. Now remember one thing, whatever formula you have in limits, derivatives and integration is only for natural log. What is natural log? Log to the base e. Here we have given log to the base x. You cannot take the derivative because you don't have the formula for that. The formula is only for log to the base e. So first we will have to apply that, and we know log of x to the base a can be written as log x by log a to the base e. So here also I can write log of x to the base e upon this log of x. Okay, we have this. Those who have problems, log of x to the base a can be written as log of x to the base b upon log of a to the base b. So the same principle I have applied over here. So log of x to the base b, log of x to the base b, because here I had base as x. So now I want to find out derivative of f dash of x. So I can go with u by v theorem, or I don't like u by v, so I'll take this term over here. So I'll get log of x into f of x is equal to log of x. Okay. Now what I'll do? Now I will take the derivative, so I'll get f dash of x. So now when I take derivative here, I will have to apply u into v. So log x constant and derivative of x is f dash of x, f of x is f dash of x plus f dash of x is constant and derivative of log of x will be 1 upon. Here log of x, the derivative of log is 1 upon, so this will be 1 upon log x into derivative of log x. I change it. So here I get log of x into f dash of x plus f of x upon x is equal to 1 upon log of x into derivative of log x is 1 upon x. I want the value of f dash of x, so this term I will take over there. So I will get log of x into f dash of x is equal to 1 upon x log x minus f of x upon x. So now the question is, I want to find out f dash of x. I don't have the value of f of x, it's okay. He wants us the value of f dash of x at x is equal to e. So when I put x is equal to e here, and here, so here also I will have to put e. So what I'll do is, first I will find out the value of f of x at x is equal to e. So at x is equal to e, my f of x can be written as f of e, which will become log of e upon log of e. Now e is antilog, so log and antilog will cancel each other. Hence, when it cancel each other, I'll get 1. Hence, log of e is 1. Here also log and antilog cancel each other, so I'll get 1. Now log of 1 is 0. So 0 upon anything is 0. So f of e will be 0. Now let's find out what is asking. Let's find out that x is equal to e. So I'll substitute, put x is equal to e on equation number 1. Therefore I'll get log e into f dash of e is equal to 1 upon e into log e minus f of e upon e. Log e, log and antilog cancel each other, hence log e is 1. So 1 into f dash of e is equal to 1 upon e into log of e is 1. F of e, what we have got is 0. So this will become 0 upon e. So 1 into f dash of e will be nothing but f dash of e is equal to 1 upon e, 0 upon anything is 0, so that is 0. Therefore, f dash of x at x is equal to e, that is nothing but f dash of e is nothing but 1 upon e. So this is our answer. Okay. So the value of f dash of e at x is equal to e is nothing but 1 upon e. So this is our answer. So everyone take the screenshot. So this week I was going to be there, but due to Moram and Onam, You guys have holiday, so I will be not be coming this week, but next week I'm going to come over there. So there again, we'll start with this. We have not yet completed because this is a very big topic. We still not have completed this derivative. We have done certain numericals, but lot of numericals do come on limits, continuity, and differentiability, which means function is differentiable, which means that derivative exists if and only if the function is continuous. So there are a lot of questions on this, if the function is differentiable or not, if the function is continuous or not, okay, and what is the limit of the function. So still we have not completed this topic. We have done a lot of different numericals of derivatives which have come in the exam, but still we have to do of continuity, limits, and differentiability. Okay, so when I come over there next time, in the next week I'm going to come over there. So at that time we are going to cover, okay, numericals on differentiability, continuity, okay. At the same time, okay, we'll also start with the new chapter, application of derivatives, and we'll see numericals of application of derivatives also. Okay, have a nice day ahead. In next 2 minutes, I cannot do new numericals, so that's it for today. Have a nice day ahead.